You know, we do it every single day. We type an address into our phone, and boom, a route appears. But behind that simple blue line, there's this incredible hidden science, a battle really between the shortest path and the best path. So let's pull back the curtain on your daily commute and see what's really going on under the hood.
Come on, we've all been there, right? Your GPS is absolutely insisting you take a certain route, but your gut, your experience is just screaming, nope, not that way. You just know there's a better way. Maybe it's a prettier drive, the pavement is smoother, or it just dodges that one traffic light that takes forever. That exact feeling, that's the whole reason this field of research even exists.
And here's the heart of the issue. A computer is amazing at finding the one single fastest route. It's a pure math problem. But we're not computers. We humans, we want the best route. And best is so much messier, right? It's about trade-offs, what we personally like, and our very real, very human desire to just have a choice in the matter.
And hey, it's not just a feeling. The research completely backs this up. This need for choice is fundamental. A truly useful navigation system can't just be a dictator barking one order at you. It needs to be more like a friendly, knowledgeable guide, showing you a few really good options.
Okay, so how in the world do you actually find these smart alternatives? Because it's not as simple as just finding the second or third shortest path. A lot of the time, those are practically identical to the first one, maybe differing by just 1 or 2 blocks. The real trick is finding routes that are genuinely different, but still make sense.
So to solve this, researchers came up with 3 main rules for what makes an alternative good. First, it needs low overlap. I mean, it actually has to take you on a different journey. Second, it's got to have a small stretch. It can't be some ridiculously long scenic tour. And finally, low complexity. It should be a pretty straightforward path, not some chaotic mess of 100 tiny turns. Those are the goals.
The really clever technical solution for handling all these options is something called an alternative graph. Now, instead of just making a list of routes, the algorithm builds this mini-map that has all the good options woven together into one structure. It's just a way smarter, way more efficient way to manage all the possibilities.
So how do you actually build this alternative graph? Well, the algorithms have a couple of really clever tricks up their sleeve. We're going to look at 2 of the most effective ones that the researchers developed, what they call the Plateau method and the penalty method.
All right, so the Plateau method kicks off with a really smart move. Instead of just searching out from your starting point, S, it also starts searching backward from your destination, T. You get these 2 searches that are basically racing towards each other, which massively shrinks the area the algorithm has to even look at.
And this leads us to the real secret sauce here, the plateau. Look at this diagram. A plateau is basically a stretch of road where the time it takes to get from your start point plus the time it takes to get to your destination stays almost the same. In simple terms, it's a detour that barely costs you any extra time. It's the sweet spot.
And here's the payoff. These plateaus are absolute gold mines for finding great alternative routes. The algorithm can just grab these segments and stitch them into the main route, and voila, you have new paths that are genuinely different but still super efficient.
Now, the second technique, the penalty method, is a totally different beast. It's more of a trial and error approach. First, it just finds the absolute shortest path. Then, and this is the cool part, it goes back and penalizes all the roads on that path, basically making them seem slower than they really are. Then it just runs the search again. Naturally, the new shortest path will try to avoid those penalized roads, and in doing so, it reveals a great alternative. It just keeps doing this over and over until it's got a nice little collection of choices.
Okay, so that's amazing. We have this fantastic set of routes that are all different from each other. But a map is just a drawing, right? It's static. The real world, on the other hand, is, well, it's chaos. And that brings us to the second, and maybe even harder, part of the problem: traffic.
This is the million-dollar question, isn't it? Having a beautiful map of possible routes is completely useless if you don't know how bad the traffic is on them. And this is where we shift gears from just looking at maps to the world of big data and predictive analytics.
And let me tell you, working with real traffic data is a nightmare. It's just messy. It's full of errors, missing information, it's noisy, you get these random slowdowns that throw everything off, and it's totally unpredictable. An accident, a concert, bad weather, none of that is in the historical data. This is a classic, massive big data challenge.
So what's the solution? Well, if you want to know which route is best for the next hour, you basically have to learn how to predict the future. The system has to become a kind of fortune teller.
using huge amounts of past data to make an educated guess.
The core idea here is absolutely brilliant. You teach the system the unique personality of every single piece of road. By crunching months, even years of traffic data, the model learns the typical speed on I-5 at 8 a.m. on a Tuesday versus, say, 3 p.m. on a Saturday. It gets to know the road.
Now, to handle all that randomness and unpredictability, these systems use a super powerful statistical tool called a Monte Carlo simulation. Instead of just making one single guess, it runs thousands and thousands of virtual what-if scenarios, all based on that historical data. What you get isn't one answer, but a much more realistic forecast of the most likely travel times.
So, does all this fancy math actually work? Oh yeah, it works incredibly well. The research shows that these models can hit an R-squared value of over 80%. Now what that means in plain English is that the model can successfully explain more than 80% of why traffic speeds change. That gives it a scarily high degree of accuracy.
So now we have our two critical pieces of the puzzle. We have a way to find a bunch of good, different routes, and we have a way to predict the traffic on them. All right, let's put it all together.
So here's how it all clicks together so perfectly. The alternative graph algorithms, they build the map of possibilities. Think of it as the skeleton of your trip. Then, the traffic forecasting models come in and provide the intelligence. They layer the real-time and predicted speeds right on top of that skeleton, letting you see the best choice for this exact moment.
And the final result is, well, it's pretty amazing. You see here, for a complicated trip across a city like Berlin, you don't just get one answer. You get a hand-picked set of high-quality, genuinely different, and traffic-aware choices. It lets you, the driver, make the final call.
And this isn't just for navigating dense cities. This tech scales up beautifully. It can generate these same kinds of smart, compelling alternatives for huge, long-distance drives across entire countries, like we're seeing here for France and Italy. So if you take one thing away from this, let it be this. Your map app isn't just finding the shortest path anymore. It's doing this elegant two-step dance. First, it builds a whole map of reasonable possibilities. And second, it uses some seriously powerful data science to predict the absolute best choice for right here, right now. And all this just leaves us with a really fascinating thought to chew on. You know, as our data gets even better and AI gets even smarter, what will the perfect, truly personalized route of the future even look like? Will it start optimizing for the best scenery? Or maybe for the best fuel efficiency? Or what if it could optimize for your mood? The journey, it seems, is really just getting started.